Okay, let's begin. Calculate the height of the wall, which is BH right here. Now the part that you have to measure outside or wherever you're going to be doing this, the only part you can measure is this length right here. And in class, I told you that it was 6.2 meters. But you're going to have to measure that on your own. Now, in order to get this wall here, the height, we've got this is 6.2. And what we're going to do is measure that angle with our clinometer or protractor. So let's redraw this triangle right here. Doesn't look like a right triangle, but it is. And again in class, I told you the elevation. Angle of elevation, 34 degrees. Doesn't look like 34 degrees, but it doesn't have to be to scale. Now we draw our diagram as a right triangle. This is the 6.2 meters. We don't know what the height of the wall is, so it's x. And the angle of elevation is 34 degrees. So what do? We use some trigonometry here. And we use our notes. This stuff. Working over here, let's do it. This should be a quick one, because it's a cheese. We have to know how to do this. We're right here. That's the opposite side. That's the adjacent side. So we're going to use tangent. So I'll put my working over here. Tangent of 34 equals opposite over adjacent, which means x over 6.2. In order to solve, I multiply because x is on the top. And I'll put it to 2 decimal places. Okay. Now just a note on this angle right here. I measure that from ground level. So when you go outside and measure that, I didn't do it from eyeball level. I lay down on the ground and you measure it from there. If you were standing up, this angle would be less. You should still get around 4.18. But your angle will not be 34 degrees. So, we're going to need this measurement here. We're going to need this calculation. So, let's continue. Okay. Metal brace is going to go from A to H. Let's draw a simple rectangle right here. With all the vertices, or corners. These are right angles, therefore we have a right angle triangle. Now, I just figured out the height of the wall right here. That's 4.18. Now, what's going on up here? I don't know, but I am given this up here. CD equals 9.2. Now it doesn't look like it because of the perspective, but that's the same distance as GH and AB, like I said in class. And we'll label this X. Now the only thing I can do here is Pythagoras. Again, from our notes. And I'm finding the hypotenuse. Now remember, it's a rectangle, so if this is 9.2, that's 9.2 up there. If you want to put it up there, great. So when I find the hypotenuse, it's pretty straightforward. Again, achieve skill. I worked this out on the calculator. And of course, the last step of Pythagoras is always a square root. And I use 2 decimal places for this one as well. Okay, just a note, remember, you don't always have to show that step because it'll show up on the calculator. You can fast forward this bit, 4.18 squared plus 9.2 squared. We get that answer. Okay, if you want to rewrite that again, you can, but you don't have to, because you just want to square root the answer, press equals, and you'll get that. Don't make a rounding mistake there. Okay, we move on. Okay, EF 7 meters. Going to be a right angled triangle there, even though they don't tell us it is, but the length is always the perpendicular shortest distance to xy. They need to know the size of the internal angles. They want to know this. They want to know that angle right there. Now, 7 meters, 7 meters. I need another side here. Hold on. Let's go back to my canopy. What am I given? CD equals 9.2. 9.2. 9.2. These are parallel and equal. Okay? So if this guy here is 9.2, I'm going to have an isosceles triangle. That hits it at the midpoint. Therefore, that length is 4.6. Half of 9.2. Okay? So we're ready to go. Trigonometry, again, I think it's going to be tangent. I know it's going to be tangent because from this perspective, that's the opposite. And that's the adjacent side. So I'll put my working over here. Tangent x equals opposite over adjacent. Don't forget, when you're solving for an angle using trigonometry, we use inverse tangent. And depending on what you want to do right here, sometimes you can just use the division sign inside the brackets. Okay? So, shift tan to get inverse tan, and then 7 divided by 4.6. Don't forget to close the brackets. Equals. Now, 56.7 to 1 dp okay, but you know how I am with degrees. I think it's just a little bit better to keep it to two significant figures because 1/10 of a degree is pretty small. So, I prefer this one. Okay? Now you can't, I don't know if you can see this too well, but like I said, it doesn't matter because you'll have this hard copy at home right in front of you. Show fully that the length is approximately 7 meters. Now this is probably one of the hardest ones on the test because of the drawing. So I'm going to help us out here. I want to show that that is 7 meters. But what do I have? Let's go back to the original drawing. That right there, height of the pole is 2 meters. These guys. So, those right there are 2 meters. This right here is the part that I measured. That's that part right there at 6.2. Very hard to see. And this is the height of the wall. Again, all about the perspective. Height of the wall was 4.18. Now, this right here is 4.18 minus the height of those posts, because that bit right there is 2 meters. So you get 2.18 for that length right there. Tricky. So I want to find out what is the actual length right there according to my measurements. Because up there they estimated it as 7. Okay, but what it is really, well, use Pythagoras and find out. Easy enough. 2.18 squared plus 6.2 squared equals x squared. That is the hypotenuse of a right triangle that is very hard to see. When I do this on the calculator, I get 43.1924, and don't forget to square root it. And I put the answer in there because we can do that step on the calculator. And I get 6.57 meters to 2 dp. Okay? So management was pretty close, estimating it at 7. Okay, next one. Drawing is important here. That's the important part. 70 degrees with the ground. Another part. Is where it joins the wall. Okay? So I have the angle of elevation right there is 70 degrees. 4.18 is my height right there. And remember where I got this problem here. is way back from problem 1. Okay, 4.18 was right there, and that's where he's going to put the ladder against the wall. So I can say that's the wall, and that's the ladder. So we'll label that X. And we have some trigonometry here. From the 70 degrees, that's the opposite side, and the X is the hypotenuse. Opposite and hypotenuse is sine. So the sine of 70 degrees equals opposite over hypotenuse. And when the variable's on the bottom, don't forget, we divide to solve. 4.18 divided by sine 70. Only when X is on the bottom. And I get 4.45 meters is the minimum length for that ladder to get a 70-degree angle to hit the top of the wall to 2 decimal places. Okay. Lucky laughed. I'm letting you read this. I'm not going to read this out loud because you can do it. Okay. What is the minimum height required for the poles to fit in? So the height of the box is adjustable. So we start with our drawing. Not fantastic, but the dimensions are 1.88 meters by 0.5 meters. I don't know my height, so I'm going to call it H. And I know that a 2-meter pole can fit inside there. Okay? And a 2-meter pole is going to go from the front bottom to the far back. And that part's 2 meters. So I want to find out the height. Well, the first thing I'm going to do is find this length. Because if I can find the diagonal of that rectangle right there, I can use Pythagoras to find the height. So I'm going to take that base of that box there, which is a rectangle, and I'm going to redraw it, and I'm going to call it X. And I'm going to solve that one using trigonometry because it's just a hypotenuse. So I get (1.88 squared plus 0.5 squared equals X squared. Okay, now that's an intermediate answer, so I'm not going to round that to 2 decimal places yet. I'll leave it to 3. Now that I know that length right there and that length right there, I can calculate the height for that right triangle right there. And don't forget, the height is not the hypotenuse there. So I've got 1.945 squared plus, remember that's the height as well, 8 squared equals 2 squared. That post stuck in that box right there is 2 meters. That's the hypotenuse. Okay, so I do a little rearranging. 2 squared minus, remember, if you're not finding the hypotenuse, you're going to be doing some subtraction in Pythagoras. So, the minimum height for my box, in order for a 2 meter pole to fit inside it, is going to be 0.466 meters. And if that sounds kind of weird, you can change that to centimeters if you want to. There's 100 centimeters in a meter, so that could be 46.6 centimeters if you choose. Either answer is okay. If you want to leave it like that so you don't make a mistake in a conversion, do so. Okay? And that's it. Good job.